Here we are looking at number 1 in lesson 12. So the answer would be number 4 for A, 1 for B, 3 for C, and 2 for D. And for this one, we are just looking at these last numbers. And so for A, you can see that it's -3. And so that would match up with 4. And then for B, you can see that it's right at 0, 0, so there wouldn't be anything right here. Letter C, you can see that it's +7, which is 3, and then D would be +5, which is number 2. Looking at number 2, the two equations, y equals x plus 2 and x plus 3, and y equals x squared plus 5x plus 6 are equivalent. Which one would help you find the x-intercepts? So the one written in factored form, which would be the y equals x plus 2 and x plus 3, because factors in the expression allow us to see when the expression is 0. So for example, it would be -2 and -3. And then number 2, which equation helps find the y-intercept? That would be when it is in standard form, because the constant term shows us the y-intercept, which would be these 6 over here. Looking at number 4, select all equations whose graph have a y-intercept with a positive y-coordinate. And so looking at these, we can see that A is a negative, B is a negative, and D is a negative right away just looking at it. And so then next, since these are written in factored form, you'll want to solve them, which I did, and this will give you a +1, and E will give you a +2. So your answers would be C and E. Okay, looking at number 7. Number 1, what are the x-intercepts of the graph that represents y equals x plus 1 times x plus 5? That would be -1, 0 and -5, 0, because if you set both of these equal to 0, or if you just find out which one will give you 0, you get -1 and -5. Number 2, what is the x-coordinate? That would be -3, because that is halfway between -1 and -5. And the y-coordinate would be -4, because when x equals -3, y equals -3 plus 1 times -3 plus 5, which gives you -2 times 2, which is -4. And then sketch a graph of y equals x plus 1 and times x plus 5. And I graphed that right down here, which is just a very rough draft of a graph. Looking at lesson 13, problem 1, match each graph with the quadratic equation. So you will get 1, 4, 2, and 3. Graph A represents 1 because you would move it to the left and it will touch right here at 1. Graph B represents 4 because it will move to the left and cross here at -3. Graph C represents 2 because it opens downward, since it is a negative right here. And then graph D represents 3 because you will move it to the right and it'll cross right here at 1. Looking at number 2 on lesson 13, complete the table without graphing. And so your x-intercepts, how you find those, since you are not multiplying it by a 0 right here, then you would flip this sign, so it would be 0, 0, and -12, 0. Same thing with this one, you would flip this sign right here, so it would be positive. And then for the third one, since you are multiplying it by a -x squared, you would not flip this sign, so it would stay positive. And same with the last one, it would stay negative. And so then finding the x-coordinate of your vertex, it is halfway between both of your x-intercepts. And so halfway between 0 and -12 is -6, and so on. Number 3, here's a graph that represents y equals x squared. So for number 1, it would move down and to the right so that the x-intercepts are at 0, 0, and 6, 0, and it would be in the 4th quadrant. And number 2, sketch the graph. So you would move it over and down so that your x-intercept right here is 0, 0, and 6, 0. Number 4, select all equations whose graph opens upward. So that means it would look like this. So what we know is if you multiply it by a negative right there, on A it's going to open downward, and then the B has a negative there too, and then D, if you multiply it out, you're going to get another negative. And so on C, I multiplied it out, and you'll have a positive 4x squared, and then E is also positive, so that would open upward. So your answer would be C and E. Looking at number 6, match each quadratic expression that is written as a product with an equivalent expression. So here I have 4, 1, 2, and 3, and around this slide I have all the work for them. So A is up here in this corner, B is right here, C is down there, and D is in the other corner. So if you have any questions, feel free to look at that work.